Hello students, welcome to my class Chemistry Gurukul. Today's topic is very interesting and it is introductory part of the new chapter of class 10, that is carbon and its compounds. Children, this chapter is very important for those students who have dreamed to take science as their subject in next level, that is 11 or 12. Okay, so this is very basic chapter for you. Just listen carefully, look into my all videos, and you will feel that interestingly you are gaining interest and gaining knowledge in a proper way. And it is really, I'm telling you, this chapter is very interesting. I don't know why students panic whenever they come across this chapter, and they think that it is very difficult, very big chapter, very lengthier chapter. But as far as my point of view is concerned, this chapter is really interesting. You are going to enjoy it. Okay children, and finally I hope you will do it yourself also. You will be able to do it yourself. Okay, so let us start this chapter, that is carbon and its compounds. Today, in spite of writing on the whiteboard, I will explain you more because this is the introductory part. Okay, so children, you come across different types of objects at your home, in your day-to-day life, like metals, plastics, you can say different types of objects you see in your home, even your surrounding also. You come across non-metals, metals, elements, even the element which we inhale, oxygen. So different things we have come across. Have you ever thought about this element which is in periodic table and its atomic number is 6? It is really very interesting element to know about. Okay, and about 0.02% of carbon is present in our earth crust. See, this is very minor number or percentage, but still it is very important element for all of us. Similarly, the percentage of carbon in atmosphere, you might have studied earlier, it is nearly 0.03% in atmosphere, apart from other gases as we have studied also, like oxygen. Nitrogen is the major gas which is present in the atmosphere, but it is still, carbon is very important. That's why we study it separately in chemistry. Okay, and for your surprise, you will come to know in this chapter that all living things, they comprise, or you can say they are made up of carbon. You will be amazed to know that we are also having the main constituent carbon. Now you will say, ma'am, how you are saying? See children, you might have seen bodies of any animals or plants died, and after that when they are burnt, the left part which is remained is in the residual form of carbon, or you can say ash. So this indicates that all the living organisms, they have this, they are made up of this element called carbon, and that's why it is kept in chemistry in a different branch and studied as organic chemistry, since it is a part of organic compounds. So that's why it is kept in a different, you can say different category and studied as organic chemistry. So children, today in the introductory part, I have already introduced about carbon. Carbon, it is having atomic number 6. So the configuration will be 2 and 4. Okay, am I right? Okay, fine. Now in our previous chapters we have studied about metals, non-metals, and there you have already studied about ionic compounds. Ionic bonding means there is always transfer of electrons, there is no sharing of electrons. So children, always remember that carbon is the unique element which has tendency to share the electrons, to form bonds, Now the question arises, what is the name of such bonds? What is the name of such bonds, children? Name is covalent bond. Name is covalent bond. From where this name has been derived? See children, if you will separate these two terms, co means in between and valent is valence. We are talking about valency, means valence shell electrons. So when the valence shell electrons are shared between the two elements, then such type of bonds are termed as covalent bonds. So today we will talk about the bonding in carbon, and it is termed as covalent bonds, which are formed by sharing of electrons. Okay, so children, when this carbon element was studied earlier, so human being means scientists, they started thinking that can we prepare these organic compounds in the lab? Is it possible? Generally these are naturally occurring compounds. They are naturally formed or present in the organic compounds like fruits, vegetables, plants, or you can say some animals. But can it be prepared in the labs? So this is also, there is a theory, there is a story behind it. I will discuss this story in my later videos, but today we are going to just focus on the bonding part. Okay, so first of all we will see how single covalent bonds are formed. Single covalent bonds are formed. Okay, suppose I have taken hydrogen and here also hydrogen. In this case we know that hydrogen has one electron in its outermost orbit. Children, here I am showing one electron of this hydrogen by dot and one electron of this hydrogen by cross. These dots and cross are nothing but Lewis dot structure. They are called as Lewis dot structure. This was given by Lewis, chemist, and to show the sharing of electrons, because if I will show both electrons by dot or by cross, you will get confused, or the examiner will also get confused to which electron you are showing. Okay, so you have to show one of the atom of electron of the atom by dot, another by cross. Okay, now sharing takes place like this. To form a single covalent bond. Why I am saying single covalent bond? Because when only one electron is shared between two atoms of the same element, or two different elements, then single covalent bonds are formed. Then single covalent bonds are formed. Now the question might be arising in your mind, ma'am, you are talking about carbon, now you are showing this example of hydrogen. So always remember that some of the elements, they are also having these type of bonds, like whenever you are writing H2, because whenever you are writing the name of any element, you never write as H, or when you will write in chemical equation form, you will never write as H, you always write it H2 or O2, okay, or Cl2. Why? Because their single atom cannot exist in the free state, because they are unstable. They wanted to acquire stability. Here also hydrogen, it is sharing one electron of it with the another hydrogen, because it is unstable. When one electron is there, it is in unstable condition. So everything on this earth, they have tendency to acquire stability. So what they will do, they share one electron with its another atom of one electron, and they form a stable, you can say stable form. So whenever you write H2, means there is a covalent, single covalent bond between hydrogen, two atoms of hydrogen. Okay, now coming to the double covalent bond. Next is double covalent bond. How it arises? I am taking one example again to show you how it arises or when it arises. Always remember, as we have seen here, when one electron are shared between two atoms, different atoms or same elements, then they form single covalent bond. However, when two electrons are shared between same element or two different elements, they form double covalent bond. They form double covalent bonds. Okay, now example of oxygen, I am taking oxygen here. Okay children, now we know that oxygen has atomic number 8. Fine, so the configuration will be 2 and 6. It means you have to show its outermost electron whenever you are showing the sharing part, as we have seen here in the case of hydrogen. Okay, here you will also show 6 electrons. I am showing by dotted here in this case 2, 3, 4 and 5 and 6. In this case I am showing it by cross 1, 2, 3, 4, 5, 6. Okay, always remember, whenever you are showing sharing or transfer of electron, in case of ionic bonds also, you have to show only the valence shell electrons, not this one. Okay, now sharing means here this has 6 electrons, this atom, oxygen atom has 6 electrons, this also has 6 electrons. So to acquire stability, how much electron it needed? Only 2. If it will gain 2 more electron, it will acquire stable condition. Here also, if this atom of oxygen will gain 2 electron, it will also acquire stable condition. So both of them, they want to get stabilized. So what they do, they share their 2 electrons with each other. Okay, so this oxygen will take 2 electrons of this oxygen atom, and this will take 2 electrons of this oxygen atom, and they will form double covalent bond. Okay children, they will form double covalent bond. So whenever you are writing O2, because generally we do not write O singly, it is unstable, nascent oxygen, it is not possible that O exists in the atmosphere. Okay, it is unstable condition. Whenever you write O2, means double covalent bond is present in between them. Double covalent bond is present between them. Okay. Now coming to the next bond, covalent bond, that is triple covalent bond. Third point is triple covalent bond. Now certain elements like nitrogen, I will show you how. In case of nitrogen, we generally see triple covalent bond. Okay. Children, we know that nitrogen has atomic number 7. Okay, again I am writing 2 atoms of nitrogen here. Now we know that atomic number of nitrogen is 7. So the configuration will be 2 5. Okay, so always remember you have to show this much of electron in its outermost valence shell. So this nitrogen atom has 3 electrons. I am showing it by dotted part. 3 4 5. Here also 1 2 3 4 5. Okay, now how much electron it requires to gain stability? We know that 3. If you will add 3 to 5, then it will become 8. So whenever it acquires 8 electrons, it will become stable. So nitrogen, it wants to be stable. So what they do, they share 3 electrons between each other and they form N2. Okay, so how they will share? This nitrogen will take away 3 electrons of this nitrogen, and similarly this will share 3 electrons of this, and they will form triple covalent bond. Here you can see when 3 electrons are shared between 2 same elements or 2 different elements, they form triple covalent bonds. Triple covalent bonds. Okay children, I hope up to this you have understood. Now from my part, I am giving you one homework or assignment to show sharing between 2 chlorine atoms. Can you do this? Okay, so let me see how much of you have completed it. In my next video I will ask you. Now coming to some of the compounds that we will discuss, in which sharing is done but still some of the electrons are left. Okay, so look into it. In case of water, how sharing of electron takes place, look into it. Okay children, suppose I am writing, see in this case you could see that 2 hydrogen atoms are there. 2 hydrogen atoms are there and 1 oxygen atom is there. Only 1 oxygen atom is there. So how the sharing will take place? In this case, you will write oxygen and hydrogen like this. Okay, and in oxygen we know that 6 electrons are there, so you will show it by 6 dotted dots, and this hydrogen by 1 cross, this is also by 1 cross. Okay, so what happens here? In this case, this hydrogen shares 1 electron of oxygen, here 1 electron of oxygen, both has got it. Okay, but what about oxygen? Oxygen gains 1 electron from this hydrogen and 1 electron from this hydrogen. So this is how sharing occurs in case of water. Fine. Now what about ammonia? If you want to show ammonia, means you could see here one atom of nitrogen is there and 3 atoms of hydrogen are there. Okay, so how you will show the sharing here? See, in case of nitrogen, you will write, if it is 1, so you will put here nitrogen, then hydrogen. Suppose I am writing it here, here and here. 3 hydrogen atoms I have shown it here. Okay, we know that children, nitrogen has 5 electrons as we have seen earlier. So in case of nitrogen also, you have to show it by this dotted structure. I am showing 3 electrons and 2 I am showing it here. Okay, hydrogen by cross, this hydrogen by cross and this hydrogen by cross. So by sharing 1 electron with nitrogen, this hydrogen has been they have become stable, means all the hydrogen have shared 1 electrons with nitrogen. They have taken 1 electron from nitrogen and they become stable. What about nitrogen here? Nitrogen will also take 3 electrons of hydrogen like this to become stable, because 5 was already present with nitrogen. It requires only 3 electrons, so it will share 3 electrons of hydrogen, and this is how you can show bonding, covalent bonding in water and ammonia. Okay children, so this is how sharing takes place in case of ammonia and water. Now one homework I am giving you for showing the covalent bond, that is, you have to show sharing of electrons in CH4, that is methane. Can you do after Cl2? You have to show sharing in case of methane. So this is it children. I hope you have liked the introductory part, and in our next videos we will see the next topic. Thanks for watching. Keep watching.